Great seeing you here again. My name is Luc de Custer, founder of the Custer Academy, and here I'm going to talk about the Agile Practice Guide, delivering in an Agile environment, and specifically about estimating and measuring in Agile projects. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So when we look at measuring progress, when we look at deterministic cycles, we have a very specific way of estimating the duration of the activities and a specific way to measure the progress. Now, when we look at the deterministic cycles and deterministic projects, the way we measure progress is not always straightforward. There may be some issues that we have, because we don't really see what has been done. We didn't create anything. So the information we may get may not be completely true or realistic. People may try to give progress in a specific way, and you always have to be careful when people are giving you a percentage complete. What does it mean 50% complete? When this compares exactly with 50% of the duration of the activity, you have to be careful. Now, the other problem we have is that we share results late with the customer. So when we finish some work, there may be some outstanding issues that are being discovered. There also may be some new requirements because we don't communicate so often with the customer. We look at all the requirements at the beginning and we consider those as unchangeable. But reality may be, in many cases, completely different. Also, we can question, what does 90% complete refer to? What does it mean? The thing is, the estimation, and typically what we see in deterministic cycles, that the people tend to get to the 90%, but then it's very difficult to get to the 100%. What does this percentage mean? Does it mean that we finished something or we just did 90% of the work? So it may be that we did a lot of work, but didn't create any value. But that's for the deterministic cycle. Now let's have a look at how we do it in Agile. Now, when we estimate and measure in Agile, it's completely different when we look at the deterministic approach. We're not going to estimate the way we did before, and that's one first change when we are going from a deterministic waterfall approach to an Agile approach. In Agile, every story has a number of points. Those points are allocated based on a relative estimation. It's not an absolute estimation. And one of the examples of these estimations is the Fibonacci estimation. We will look at that in the next slides. We will talk about Fibonacci poker, and the people are trying to give a value, an effort to these different user stories. Now, when we plan a project in Agile, we plan to complete several story points per time or iteration. And we can relate those to the value we created because the user stories give us some value. Every user story provides us some value. Of course, with spikes, we don't have the real value, but we're studying. But in other examples, the completion of a user story will lead to some specific item that has been created and that has a certain value. Now, later, the team will also measure the completed story points. The story points that we completed in a cycle, in a sprint, or that we are completing in, let's say, in a flow-based approach like Kanban, that gives us information about the future estimates. We can estimate the things that still have to come based on that experience. Now, these are the elements that we have, in fact, based on the experience, how we are doing the different things. Let's now have a look at the principle of the Fibonacci estimation and the Fibonacci poker. Now, we have a relative effort estimation. We are not going to say an activity will be completed in a certain time. No, we say we estimate that the effort to make this or to complete this user story has a certain value expressed in points. And we compare the different activities and we look at a story with high number of points means that it takes more time, more points to complete a user story with a lower estimate. Now, the basic of this estimation is the Fibonacci series, and we know that from the Da Vinci Code. We've seen a lot of theories about the Fibonacci code. We talk about the golden ratio, things like that. The original Fibonacci series starts with 1, then 1, 2, 3, 5, and so on. So basically what we add is that we add the next number is the sum of the two previous ones. So 3 is equal to 2 plus 1. 5 is 3 plus 2, 8 is 5 plus 3, and so on. Now for Agile, for Scrum, for the estimation, we create a different set of numbers. So we modify this for Agile and we find half, 1, 2, 3, 5, 8, 13, 20, 40, and 100. And we see at the beginning it's quite similar as the original series, but later we go to 20, 40, and 100. One of the elements also is that we try to have stories when we are planning for a Scrum, that we have maximum, for example, 13 stories per activity to complete. If we, for example, have a story which has 100 points, we will split it in 2 of 40, 1 of 20. The 40s we will also subdivide, and we find shorter activities that we can complete in a reasonable time. A user story with 100 points, that will be very difficult to measure, to complete, because it's too complex and we will not see any results too quickly. An important element is what we call velocity and estimating progress. Velocity is basically the time or the number of points that we complete in a time unit, in a sprint, for example. Now, when we look at the beginning of an Agile project, one of the bigger issues here is that it's very difficult to determine how long the project will take to complete. And that's one of the management issues we may encounter, because the management wants to know when will this project be completed. And basically, we can give a rough estimate, but we don't know how the cycle, how the iteration, how the flow will in fact actually go. So we don't have that estimation. That's one of the elements that we have to identify. We can have an estimation based on experience, but once we start working on the different iterations, we can find the velocity. And the velocity is basically the number of story points per iteration. And we can look at the story points completed in a specific iteration, but we can take an average about the last 2, 3, 4 iterations to have a more realistic effect, because you can imagine that it's not always the same. There may be some variations around, let's say, an increasing velocity. So we try to find an average, and once we know how many points we still have to make, how many points we already finished, the time we were already working on the project, how many story points do we still have to complete, so we can calculate the number of iterations, the number of scrums that we do, the sprints that we do, and we know that the duration of a sprint is fixed, so multiplying the number of points per sprint and looking at the number of sprints, we can find the expected duration, the remaining duration of the project. It's completely different than in a deterministic approach, where we will be looking at the SPI, we will be looking at the Gantt chart. We don't have those here. When we have a flow-based iteration, we see that the elements are in fact having a flow. We see how many points we are in fact realizing or completing per time unit. And again, the remaining points, we know how many points we make, the velocity. So when we take the number of points divided by the velocity, we find the time that we still have to continue working on the project the time until the project will be completed. To visualize the different elements, we have what we call the burn down, the burn up, and some combined graphs. The first one is the burn down chart. So the blue line represents the number of points, user stories that we want to finish over time. And we estimate that that will be linear. So we start with all the points to finish until all of them are finished. And then we see what is the reality. How many points did we already finish? And we have to compare it with the top. So the red line here means that we are not creating the user stories, finishing the user stories, creating the user points as we plan. So we're basically lagging behind and we have to do something about it. Now there are different ways. When you look at our videos about Agile, you will see that there are different elements, different issues we can identify just evaluating the burn down chart. The burn up chart is the opposite. We have now we are representing, in fact, how many units, how many points we expect to create over time. And we see that this is an increasing line. Now we expect to finish everything at the end. And the orange line is showing what already has been created. And here again, we're basically behind. So we have to find out what are we doing, what is going on. And we can combine all those charts together. So we have the orange, which is the representation of the number of story points that have been created. And the red line is showing the number of story points that we still have to realize. So these are the three charts which are very important for our Agile project. Though we see what the work we did, and we can use this for all different types of Agile methodologies. We also speak about the Kanban board. We can use the Kanban board. Here I have the project White Lion. Now, what we have the backlog. We put the things in the sprint. These are the things we want to do. And then we look at ongoing. We have the quality review. And finally, these are finished. So we can go through them and we can identify here the cycle time. The cycle time is the time from the moment that an activity has been put to ongoing, we start working on it till it is completed. And then we also have the lead time. It's the time that its story goes from the backlog to being finished. And these things are very flexible. We want to see how this is going, how this is working. We can use the same board for sprints and for the Kanban. We also have a feature chart. We want to look at the feature chart. We look at the numbers of features that we have to complete, the number of features that have been complete, and the number of features still to complete. Now here we have, first of all, the blue line gives us the total numbers of items that we have to complete, or the features. The completed items line is going up. The farther we go in time, of course, we complete more and more items. And at the end, we will see that they come together. And then we have the remaining items. How many items do we still have to complete? So basically, those elements that we find here is about the features that we wanted to realize. Where are we? Features can change, so the total number of items can change. We see that from the beginning we had less items, then at the end we have more. But it can also be that over time, due to the planning and the user stories, we have a different number of items. It's not always constant when we look over time. So these are very flexible to adjust, but it shows us where is the project going to and what are the items that we already created and what do we still have to complete. An element that we also can consider are the EVM parameters. We've seen them before. Now, basically, we can use them also in the earned value man, or in Agile, we have the similar approach. Just saying that the green line is the planned value over time. And when we look at a specific status date, we see that we planned a specific value. The orange line is the earned value. That's the value that has been created. Basically, this means how many deliverables did I create and what was the estimated cost of those deliverables. And the yellow line, actual cost, shows us how much we actually paid to create those deliverables. Remember that we had the schedule variance, the cost variance. We can also define the SPI and the CPI parameters here. Now, when we have these elements, we can also look at the estimates at completion. And when we look at the estimates of completion, there are different elements and different formulas that we can use. We can look at the project manager's estimate. Like we said before, the project manager is the person who knows the project the best. This means that this person can give a specific estimate without any calculation, but based on experience, using the numbers, looking at the evolution, looking at the team. The project manager is basically the best person to give an estimate. Now, in order to have some objective calculations, we can define three different types of estimates. First of all, we have the mathematical estimate at completion, the CPI-based estimate at completion, and the CSI-based estimate at completion. Now, the mathematical estimate at completion is basically suggesting that from the status date, of course, we already have spent the actual cost. We cannot go below the money we already spent. But we can say from now on, the remaining value, which is the budget at completion minus the value created, minus the earned value, is in fact working as we planned. So the CPI will be equal to 1. We are spending $1 per value of $1 that we create. The other thing is the CPA-based estimate. And here we assume that the way we're spending money will be the same CPI as we measured before. And then the formula is a little bit more difficult because we have the actual cost, but now the remaining value, the big back minus EV, will not be performed, will not be generated with a CPI equal to 1, but we have to divide by the actual CPI. And the CSI-based estimate is basically the same principle, but now we have a more pessimistic approach. We take the CSI as parameter and we say, or the CSI is defined as the CPI multiplied with the SPI. The mathematical estimate is typically considered to be the optimistic estimate. The CPI-based estimate is considered to be the probable estimate, and the CSI-based estimate is considered to be the pessimistic estimate. Typically, what we want to do is to see that the project manager's estimate is somewhere in between, and we can also calculate an expected cost at 50% probability. We can look at 84% probability using the normal distribution, and we would expect that the project manager's estimate would be somewhere between the average and the average plus 1 standard deviation. So that's basically what we expect to have, but the project manager can give a different explanation. This is a good way to have an objective evaluation of the different estimates. The last thing that we're going to look at are the EVM parameters in Agile. Now we have the same element, the same graph. We can adjust the earned value management parameters to use in Agile. And here we consider two elements. We look at completed and planned features. I call this the expected value of features and the planned value of features. When we look at the cost of those features, earned value and planned value, they have basically the same cost. And when we compare those two, we will see what is the efficiency with which we create new features. And we can compare those two, defining a new SPI. The other element is that we can look at the value we created. What is the value of the earned values of the features that we created, and how much did we actually pay to create those? And based on this, we find an adjustment of the SPI and the CPI. The SPI is in fact equal to the earned value features divided by the planned value features. So we have the number of features divided by the planned features, which is similar to the earned value of the features, the cost, the value of the features, and the value of the planned features. How much did we create? How much did we get up till now in this project. Same thing for the CPI, but here we use the dollar numbers. We have the expected value expressed of the features expressed in dollars divided by the actual cost of those features also expressed in dollars. So basically this was it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.